All right, stats. So chapter 6, talking about parameters and statistics. Okay. So this is sort of the start of a 3 to 4 chapter kind of repetitive idea here. Okay. So in chapter 6, we're talking about what a sampling distribution is. We will use sampling distributions all throughout the next couple chapters. Okay. So again, 6.1, what is a sampling distribution? Okay. Well, before we get into that, we need to talk about, like I said, statistics and parameters. So a statistic is a number that describes some characteristic of a sample. So think of S and S, right? Statistic, sample. A parameter is a number that describes some characteristic of the population. So again, P for parameter, P for population. Now, this is an important note here. To establish the value of a parameter, which is usually unknown, and again, we talked about early on in, I think, chapter 3, that it's very difficult to get every person's opinion in the population, right? That's the only true way we could really get the exact parameter. So again, in order to get this parameter, we need to use a statistic calculated using data from a random sample from the population, okay? And again, this is going to be where most of our inference methods come into play. So inference, using a statistic to talk about the parameter. This box is very important here. So in this box, we're going to link what the sample statistic looks like compared to what the population parameter looks like. So for mean, the sample mean is X bar. And for the population mean, or the true mean, is mu. For proportions, percentages, the sample proportion is P hat, and the true proportion or population proportion is P. And then for standard deviation, the sample standard deviation is X, sometimes called SX, and the population standard deviation is sigma. Okay, and then again, note for parameters and statistics without symbols, the word true and sample should be used to distinguish population from sample. Okay, so be aware of that. That's all about when you're talking and identifying. So again, if you would try to use the math type in Edulastic to get your X bar and your P hat. P hat and mu and P and sigma. P hat is tougher to get, so if you just put P hat, that'd be fine. But X bar, you should be able to get X bar pretty easily. All right, so example 1 here says identify the population, the parameter, the sample, and the statistic for the following setting. So it says a Pew Research Center poll asked 1,102 12 to 17-year-olds in the United States if they have a cell phone. Of the respondents, 71% said yes. So when I do this problem, okay, I'm going to list out population, POP, parameter, sample, and statistic, stats. Okay, so again, you can write them out how you want to. I wrote out parameters, so why not write them all out? I like to actually focus on the sample and the statistic first because they give me numbers. The sample here is the 1,102 12 to 17-year-olds in the U.S. Sampled, right? Or asked, or polled, right? Polled. 1,002 12 to 17-year-olds in the U.S. that were polled by Pew Research Center. Okay, now again, you can't, this is the word polled, P-O-O-L. I think that's a word. You could probably cut it off here if you wanted to. I'm okay with that, right? So you could, but I like to be wordy. So then what is the statistic? Well, the statistic is the percentage who said yes, they have a cell phone. When you see percentages, you need to think of proportions. This is a proportion problem. So instead of using 0.71, we're going to use, or instead of using 71%, we're going to use 0.71. And our statistic here is the sample proportion P hat. So p hat equals 0.71, the sample proportion of 12 to 17-year-olds in the US who have a cell phone. Okay. All right. So again, that's what yes meant. Yes meant they have a cell phone. Okay. Next, so now let's use these ideas to find the population. So if the sample is the 1,102, 12 to 17 year olds, then the population is all 12 to 17-year-olds in the US. Okay, again, they're not the polled ones, they're just all. So again, remember that word all is very important when you talk about the population. And then the parameter, if the statistic is p hat, then the parameter is p, which equals the true proportion. And we don't really know what that value is, okay? Which equals the true proportion of all 12. I always put the dash, I don't know why I do it, to 17-year-old in the US who have a cell phone. Who have a cell phone. So again, I kind of do this bottom to top method, right? I start with the sample, which inevitably includes actual numbers, and then I just generalize that to the population by including all and the word true. Okay. So hopefully that makes sense as you look forward to your homework. All right, good. So parameters and statistics, very important. Objective 2 is coming.